Does an inverter have built-in safety features for grid protection? Breaking news in the world of renewable energy. The question on many people's minds right now is whether inverters come equipped with safety features to protect the electrical grid. With the increasing use of solar panels and battery systems, understanding these safety measures is more important than ever. Let's get into the details to clarify this topic for you. Modern inverters, particularly those used in renewable energy systems, are designed with multiple safety features. These features are critical for protecting both the grid and the inverter itself. A key safety function is called anti-islanding. This feature detects when the electrical grid goes down. If a power outage occurs, the inverter disconnects from the grid immediately. This prevents it from sending electricity back into a non-functioning grid, which could pose risks to utility workers making repairs. Inverters also keep a close on grid voltage and frequency. If these levels fluctuate outside safe limits, the inverter will stop supplying power to the grid. This action protects household appliances and the grid infrastructure from potential damage. Some advanced inverters can even detect rapid changes in grid conditions, allowing for a quicker response to issues. Additionally, overcurrent and short-circuit protection are standard features in modern inverters. If the inverter senses excessive current flow, it will shut down to prevent damage to its internal components and the electrical system. Thermal sensors are also included to guard against overheating, which can happen during high demand or fault conditions. For battery systems, such as those using lithium-ion technology, inverters work alongside a battery management system. This system monitors cell voltages, temperatures, and current to avoid issues like overcharging and thermal runaway. This coordination is essential for safe operation, especially in home energy storage setups. Inverters in solar and battery systems frequently include ground fault protection. This feature detects unintended current paths to ground, which could signal wiring problems. When a ground fault is identified, the inverter disconnects the affected circuit, reducing risks of shock or fire. Some inverters also provide additional safety features like arc fault detection. This identifies dangerous electrical arcing that could potentially ignite fires. Surge protection is another common feature, shielding against voltage spikes from lightning or grid disturbances. Manufacturers design inverters to meet international safety standards. These standards set minimum requirements for grid protection, electrical isolation, and fault response. Compliance is verified through rigorous testing and certification processes. In summary, inverters are equipped with multiple built-in safety features for grid protection. These include anti-islanding, voltage and frequency monitoring, overcurrent and short-circuit protection, thermal management, coordination with battery management systems, ground fault and arc fault detection, and surge protection. These features ensure safe interaction between inverters, the electrical grid, and connected devices.